we are going to learn about photodetectors, that is optoelectronic devices which will be converting the light energy into electrical energy. So we are going to have three types of photodetectors. They are namely solar cells, PIN diodes, and avalanche photodiodes. So coming to the solar cell, the working principle behind the solar cell is that it is going to convert the light energy into electrical energy. So when light is falling on the cell will be generating a voltage across the terminals, and this voltage will be increasing with the increase in light intensity. So here we can see in this diagram the symbol of a solar cell will be having a battery symbol. Above this we are going to have arrows indicating that light is being incident on this one, voltage is being generated. Next, construction and working of solar cell. First, we'll see the construction of the solar cell. Basically, it is a PN junction diode. So we can see here we have the P-type material here, and above which we are going to have the N-type material, and in between we are going to have the depletion region. And above this one we are going to have a glass window. The light which is incident on that one will be passing through the N-type region into the depletion region. And here you can see the N-type region is made thin compared to the P-type region, so as to allow the light which is falling on that one to penetrate through it and reach the depletion region. And here we can see the metal rings here. These are the two metal rings which are used for the electrical contact. So these rings are the front electrical contact, and below the P-type will be having one more electrical contact that is called as the back electrical contact. So whenever light is falling, that is whenever the solar energy is incident on this solar cell, that is when light is incident, that is, light, it is consisting of photons. So when photons are incident on this region, in the depletion region the photon energy will be absorbed and the electron hole pairs are generated here. You can see by absorbing the photon, one electron is generated and one hole is generated. So electron hole pairs are generated. The electron which has been produced in this depletion region will be moving towards the N-type region. You can see here the electron is moving towards the N region and the hole will be moving towards the P region. So the electron which has reached the N region, since it is going to come across this metallic contact, it will be passing through this metal wires which are connected to this metallic rings. So we are going to have this conducting wires. Through the conducting wires these electrons will be passing, constituting the current here. To measure the current we are going to have one ammeter here. So when you are placing one load here, so the current will be passing through that load. Now if you are using a single solar cell, the output we are going to get from a single solar cell is about 0.5 volts to 0.6 volts, so which is very much small. So in order to get a large amount of voltage, the solar cells are connected either in series or in parallel. So we can see here a large number of solar cells connected. So we call this one as a solar panel, where we are going to have a large number of solar cells connected. When solar energy, that is when sunlight is falling on this depletion region, then by absorbing this photon energy we'll be having the electron hole pairs created. So these electron hole pairs will be moving towards the electrons will be moving towards the N-type region and the holes will be moving towards the P-type region, because the depletion region, it is going to have some internal electric field. So this electric field will be forcing the electrons to move into the N region and the holes moving into the P region. So these electrons which have come into the N region, since we'll be having one metallic contact there, through that metallic contact it is going to pass into the electrical wires which are connected externally. So here we can see the electrons will be passing through these conducting wires, and when you're connecting a bulb, a load, then the current which is going to pass will be making the bulb to glow. So this is the working of solar cell. Next, the VI characteristics of solar cell. So we have this graph drawn for a particular intensity of light. We are taking the voltage along the x-axis and the current along the y-axis. So we can see here when the voltage is equal to 0, the current is going to have the maximum value, which is called as the short circuit current. Now as the voltage is increased, slowly the current will be decreasing and the current will become equal to 0, and the particular voltage value we call it as the open circuit voltage, which is indicated by VOC. VOC. And here we'll be having the maximum power point. That is, the power at the bend of this curve is going to indicate the maximum power point. And the corresponding voltage is V maximum, and the corresponding current, we call it as the I maximum. And the area under this rectangle, that is the largest rectangle that can be formed under this IV curve, that area will be giving us the useful power. So that useful power is given by P maximum, that will be equal to V maximum into I maximum, that is Vm into Im. And the ideal power of the cell is given by VOC into ISC, where VOC is the open circuit voltage and ISC is the short circuit current. So we can define the fill factor as a ratio of the maximum useful power to the ideal power. So P max is the maximum useful power and the ideal power is given by ISC into VOC. So the ratio of the maximum useful power to the ideal power is defined as the fill factor. Efficiency of the solar cell is defined as a ratio of maximum electrical power output to the radiation power input to the cell. So we can see here efficiency neta is given by Pm by Pin, where Pm is the electrical power output and Pin is the radiation power input. And it is considered that the radiation power on the earth is about 1000 watt per square meter. So if exposed surface area of the cell is A, then the total radiation power on the cell will be 1000 into A in A watts. So efficiency of the solar cell is given by Pm by Pin, where Pin is given by 1000 into A, where A is the area of the cell. The material used for the solar cells are silicon, germanium, gallium arsenide and cadmium arsenide, etc. Criteria for the materials to be used in solar cell are that solar cell materials should have a band gap from 1 electron volt to 1.8 electron volts, and they must have high optical absorption, and they must have high electrical conductivity, and the raw materials must be available in abundance, and the cost of the material must be low. Advantages of solar cell: there will be no pollution associated with it because it is the solar energy we are going to use for this, so there will be no pollution associated with this, and it is going to last for a longer time, and it is going to have no maintenance cost. Disadvantages of solar cell is that it has high cost of installation and the efficiency is low, and we know during a cloudy day and at the night times will not be able to get the solar energy. So this is the disadvantage of solar cell. Uses of solar generation systems: we can use them to charge the batteries. They can be used in light meters. They are used to power calculators and wrist watches, and they can be used in spacecraft to provide electrical energy. So we can see the applications of solar energy here for the fans, for the spotlights, for cell phones, coolers, fluorescent lightings, televisions, sump pumps and laptops. We can use them for the solar cars also, and we'll be using them for the satellite panels.